Welcome back to the Automation Podcast. My name is Sean Tierney from Insights in Automation, and this week on the show, I meet up with John Vanderpass from Rockwell Automation to learn all about their Armor Kinetics distributed servo drives. But before we get to that, I want to thank our sponsor who makes this show possible, theautomationschool.com. If you know anybody looking for PLC HMI or SCADA training, please send them over to theautomationschool.com. And with that, let's learn all about Armor Kinetics. John, thank you for coming on the Automation Podcast. I am excited to learn about Armor Kinetics. But before we jump into that, could you please introduce yourself to our audience?
Sure. My name is John Vanderpass. I'm a product manager within the motion division within Rockwell Automation. I've been with Rockwell about 12 years now. In addition to that, I've got another 21 years of industry experience, all centered around motion control, automation, and even drive control. So with that, I'd like to introduce what we're talking about today. As mentioned, it's the Armor Kinetics distributed servo drive platform. It's a new release, just new to the market in late July of this year. So before we get started, I always like to talk about the why, right? Why are we bringing Armor Kinetics to market? What problems is the platform trying to solve? Well, the reality is in today's marketplace, manufacturers and OEMs are faced with continuous pressure to try and make machines or manufacture machines that are flexible and scalable, easy to assemble, take up a small footprint, right? Looking for modular manufacturing. The intent here is to be able to react to where the market is going, right? To have that flexibility to make multiple products using the same asset, to fit as many assets into a specific square area as possible, because floor space is at a premium, and just make it a lot easier to install, maintain, and support as we go forward. So if you think about that, what are customers looking to have in their products and products from Rockwell that will allow them to achieve that flexibility, right? So they want something that can, roll with the changes, so to speak. So if they need to do another SKU, another product on a particular line, how easy is it to adapt the existing assets to that? They want to maintain a high level of quality and throughput, right? So they want to identify issues well before they become uh, impactful to the quality of the product that's coming off the line. So they want to have that early warning indication of something going on, and then when they do find something, to be able to quickly address it and maintain their production. And that speaks to the last one too, right? Is improve uptime. Um, at the end of the day, if product isn't coming off the line, orders aren't being filled, customers are getting disappointed. So we want to avoid that. So what can we do to achieve these three stated goals that we have for our customers? So the architecture that Armor Kinetics is a part of, right, it is something that uses an architecture called decentralized design. And what I'm trying to contrast here is the differences between a decentralized design and a centralized design, which is the way that we've been doing it forever, right? We have motors generally out on the machine. We have an electrical enclosure that has all of the controls hardware that is necessary to control those motors, right? So we've got power supplies, we've got drives, we have PLCs. Um, the end result is that cabinet gets really big. As we know, we keep on adding more and more drive controllers to control more and more motors to, um, uh, at the end of the day, have different features and options that our customers need. So aside from having the large enclosure, there's a lot of wiring that is required to put that kind of architecture in place, right? Think of this, all those drives are sitting in that cabinet. Every drive has to be wired to the appropriate motor out on the machine. So that's a lot of cable, that's a lot of labor, that's a lot of cable supporting structure. And it also is a little bit rigid, right? That cabinet has to be somewhat centrally located. So that either has to be on the machine, which means it's blocking a lot of the process view, the lines of sight, or it has to have a position out on the floor freestanding someplace. So that makes it a little bit inflexible.
Hey everybody, just wanted to quickly break in here and thank our sponsor, theautomationschool.com, for underwriting the cost to produce this episode. If you know anybody looking for PLC HMI or SCADA training, please mention theautomationschool.com to them. And with that, let's get back to the show.
In addition to that, by having all those drives in a cabinet, guess what we get? We get a lot of heat, right? So that heat is being exhausted into the cabinet, which means generally we have to have large air conditioners to regulate that environment to make sure those components continue working properly. So, while we've done this forever, there's some room for improvement. So if we go to the decentralized design concept, the idea here is to take the drives and put them out on the machine, right, with the motors. What we're going to talk about in a bit is, a product that we have that is both a drive and a motor, so it's an all-in-one product, or we have standalone drives that sit out on the machine as well. The end result is all those drives, given the fact that they're not in the cabinet can get smaller, right? So it takes up less space. It'll be easier to integrate it into your design, make it less likely you're going to have a freestanding enclosure. It'll also make it less likely you're going to have, air conditioning attached to that cabinet with all the maintenance that goes with that, right? I think anybody that's been in a manufacturing facility has walked by air conditioners that are not working. The doors are open, dust and whatever is getting into the cabinet. Likely there's a bucket of water that's spilling out onto the floor from the condensation. So that's a maintenance nightmare, right? As far as wiring with this type of architecture, there's one cable that goes from the cabinet to the first unit on the machine. And then that first unit is connected to a second unit and a third unit and a fourth unit. So in a daisy chain fashion. So this makes the cable consumption go down considerably. So think about raw material savings, acquisition costs. The supporting structure doesn't have to be there for all those cables that were typical of the centralized design, right? The fact that they're sitting out on the machine makes them a lot easier to, maintain and support because your indications are right out on the machine. You don't have to dress up in the safety gear in order to open up the cabinet to see what's going on. So there's advantages there as well. So definitely a lot of advantages here in terms of going to that decentralized design. End result is, that cabinet gets smaller and the machine gets smaller typically too, particularly if the cabinet is embedded in the machine. So just some of the highlights as far as, what the benefits are as far as the decentralized design. It provides savings in design and engineering time, right? Because again, because the modulars are sitting out on the machine, you don't have to go into the panel and rearrange that anytime that you want to add another option. You just add another unit on the end of the line, and generally you can do whatever you need to do from that point on. So you don't have to worry about spare space on the panel. A lot of times when you purchase a new machine, you ask for additional panel space reserved for whatever comes in the future. This makes that less critical to have that spare space. Installation time is decreased, right? All the cables for this architecture are connectorized. So really it's just, connecting connectors, which eliminates a lot of terminations that you'd have to do. In terms of changeover time, because they're connectorized, maybe you have some units in play when you're making one product and others for another, because you can just plug into what you need. That certainly decreases the amount of time there. Because everything's connectorized, you don't have as many wiring error potentials. A lot of times wiring errors are come into play when you're going to commission a machine, and that can cause a lot of downtime and a lot of headaches. Replacement, because this is modular and connectorized, it's just, taking the old one out and putting a new one in and putting the connectors on. We talked about the enclosure floor space savings. Certainly, that is, one of the huge benefits of this. And generally speaking, the overall system cost goes down as a result of this. So you think about the hardware cost savings, as well as the total system cost. If you think about labor, for example, right? Not necessarily acquisition cost, but certainly it's consuming bandwidth in your manufacturing in order to do the centralized design relative to the decentralized.
I want to jump in here just for a moment. I remember at an automation fair, actually listening to a customer explain why they use these on-machine components. Of course, the Armor Kinetics is new, but they were saying, the product is a little more expensive because it has to be, rated to go on the machine. But the manufacturing, and this is to your point you just made, the actual putting the system together, everything becomes plug and play with all the quick disconnect cables. And so the actual cost, the labor cost to put the system together is so much less, but the real savings for them was time. They were able to get machines done so much quicker because they just bolted everything together and plugged it all in. You didn't weren't wiring everything to terminal strips and then wiring those terminal strips to the field and all the checkout, like you just went through, all the checkout. So, I think a lot of people they say, oh, on machine, that's going to be more expensive because the product has to actually live in the field. But, if you're an OEM or system integrator, this can save so much time and so much labor that it can really be a game changer as far as how fast you can turn the system around. And I just want to throw that out there because I've always remembered that presentation from that customer because it was so eye-opening. And I'll turn it back to you, John.
Yeah, you're spot on with that comment. If you think about a centralized design, typically you have a panel that's built somewhere else in the facility, right? All the components are mounted on a panel and they meet up with the cabinet on the floor, and none of the other units can actually be tested or configured until that point. So there's this dependency on that centralized cabinet. In this case, the particularly the DSM, which is the integrated drive and motor, that's mounted, along with all the other mechanical components that are on the machine. IP addresses can be set ahead of time. If you really wanted to, you can manufacture it as modules and have a test processor, PLC, controlling them in those, manufacturing cells. So, yeah, spot on. Definitely a huge benefit there. So, introducing what we're talking about in terms of Armor Kinetics, I'm going to cover essentially what it is in terms of the key products, right? But first, I have to stress that this product is an extension of our existing Kinetics 5700 platform. So I know a lot of listeners out there probably have experience with the Kinetics 5700 platform, which, just to clarify, that is the drive platform that is typically used, as far as Rockwell products in a centralized design. So those drives are intended or designed to be mounted in a panel and in a cabinet. Now, by virtue of making it an extension of the 5700, the user experience is almost identical, right? So if anybody's used a Kinetics 5700, it can, they'll easily pick up on, how to configure and commission these Armor Kinetics products. In fact, the control base, the firmware base, everything is identical. The features are the same.
Nice.
So a huge benefit there. So like I said, we have a DSM, which is a distributed servo motor. So that's motor and drive combined. But the more we talk with customers during the development of this product, we realize that, having a limited number of drive motor combinations wouldn't meet all needs. So from that point on, we decided to offer the drive as a standalone unit as well. So this has a lot of the benefits of the DSM, right, as far as reduced cabling, but it is essentially a drive that sits out on the machine, and then you cable to a nearby motor. Again, everything connectorized. But what that does is allow you some flexibility in those situations where maybe the drive motor combination, because we're putting two units together now, it's bigger than the traditional motor. Maybe it doesn't fit, right? So this small drive, really fits into all kinds of nooks and crannies on the machine. It allows you that escape clause in terms of physical constraints, but it also gives you some scalability in terms of safety, for example, right? Because again, the integrated unit will just have an onboard safety encoder, so you'll be able to get safe torque off up to SIL 3 level with that. But for advanced safety, like safe limited speed, that goes up to a SIL 2 on the DSM, which in most cases is plenty, right, for applications. But for those situations where a SIL 3 level is required for advanced safety, That DSD unit allows you to do that because it does have the motor and feedback connections on board as well. Um, so that's why we developed that.
Hey everybody, just breaking in here with a quick message from our sponsor who underwrote the production costs for this week's episode, theautomationschool.com, and today we're featuring their PAC Basics Extended course. If you know anybody who needs to get up to speed on ControlLogix, everything from picking out parts, laying out a system in IAB, to actually creating your first program, testing your I/O, forcing things on and off, and even to writing full programs from scratch, integrating plant packs, integrating VFDs. Have them check out PAC Basics over at theautomationschool.com. This is a forever course. You buy it once, and you can take it as many times as you need to. You can come back for refreshers whenever you need. You also get full instructor support with your enrollment in the course, and you even get the new 2024 edition of the course completely free. So again, it's PAC Basics Extended Edition over at theautomationschool.com. And now, let's get back to the show.
Also, each unit, whether it's a DSD or DSM, has connections for a hybrid cable. So it has an in and an out, right? So the first unit would take the comms and power coming from the cabinet via one cable, and then the next unit would be connected to the outgoing port, and that can be any combination of DSMs and DSDs, right? So at the end of the day, you have a really compact offering here. I think I have some dimensions on these as we go forward, but generally, they're very, very small footprint, high power density, which gives you a nice wide power range up to 5.5 kW.
I can see the DSD being useful on retrofits where there wasn't enough room to put the DSM, right? Or in applications where the user already has like so many of this one servo motor and they don't want to, they stock it, they inventory it, they get them all over the plant and they want to be able to put this new DSD on because they can use the existing servo motors they have but now upgrade to the on-machine Armor Kinetics. So but for new applications, I can definitely see if you can design it in the DSM all in one, like you said, with everything already built in, and you're saving the price of cabling too, right? Because now you don't need the cable from the drive to the servo motor.
Yep. Again, excellent point. The DSD will actually pair up with a variety of motors, right? So obviously the VP motors, which is what's used in the DSM. So if you're thinking VPL motors or VPH, VPF, those are all supported by the DSD, as well as legacy motors from Rockwell, like the MP series, right? Those can be supported with the DSD. Linear motors can be supported by the DSD. Induction motors can be controlled by the DSD, both open loop and closed loop, if you have sine, cosine, or incremental feedback available there. So very powerful, compact unit right there in terms of the DSD.
Excellent.
So how does the architecture look like, right, with the Armor Kinetics? How does this play out? So I'm showing a diagram for those of you that can see it. Essentially, we have what is in a cabinet, right? So what we have in the cabinet is the typical 5700 layout, right, where you have a power supply and you have in-cabinet inverters. What you can do, though, is add in what we refer to as a power interface module. And the power interface module basically sits on the DC bus, just like the inverters do, being fed by the power supply. But what the power interface module will do is it will take both DC power and communications and connectorize those out to the machine as one hybrid cable, right? So that's why what I was referring to earlier when I said one cable comes out from the machine. So from one PIM, you can connect to up to 24 different axes out on the machine, any combination of DSMs and DSDs. If 24 isn't enough and you have enough power supply there, you can add a second PIM. And if that's not enough, a third, and so on and so forth. The other thing that's really nice about this is it gives you the potential of having a hybrid solution if that meets your needs, right? So it doesn't have to be all Armor Kinetics or all 5700 in cabinet. It can be a combination of two. And there's some energy efficiencies associated with that as well, right? Because they're all sharing the same DC bus. Sometimes units are taking power off the bus, sometimes units are putting power on the bus. So there's this bus sharing, as we refer to it, right? So rather than taking that energy and putting it across a resistor and bleeding it off into heat, this has a better sustainability message associated with it, right? So it's saving energy by virtue of doing that. This diagram also shows the daisy chain configuration, right? So you're going out to the first unit and then from there to the second and so on and so forth. When you get to the end, you can connect the communications back via an adapter connection to the last unit to provide what we call a device level ring. And that gives you redundancy in terms of being able to see the units from two directions. And this really becomes powerful if and when you should ever have an issue. If you didn't have that return path or that second way of looking at it, you wouldn't be able to see beyond the first unit that failed, right?
Mm-hmm.
In this case, you can isolate specifically which one is having a potential issue. This also shows the DSD, connected to a motor, right? So this is a little bit like the traditional, except for the drive is sitting out on the machine, and then you have a nearby motor that's associated with that. For any one of these strings coming off the PIM, you can have up to 140 meters of cable length from the exit of the power interface module to the last unit. So this kind of shows you some of the flexibility associated with this architecture.
So 140 meters total. You got 24 axes total. Minimum cable distance 0.5 meters, max 30 meters. So any two DSMs or DSDs could be 30 meters apart, max cable length. All right, that's a lot of technical info. I guess the one thing I'm worried about or thinking about, not worried about, is what's the max power? Do we know, like, is there a max power draw that we can do before, like, well, we can't do 24 because we have, three of the biggest DSMs that you guys make. Is there a max power?
Yeah, the maximum power coming off the power interface module is 15 kW.
Okay.
Right? And you're spot on. If you use the biggest size unit, for all your axes, you probably won't get to 24.
Yeah,
right?
yeah.
So, but again, you have this flexibility of adding a second PIM or a third or so on and so forth. The 15 kW matches up well with the Kinetics 5700 P70 power supply as well, that same exact ratings. So it makes it a little bit easier for the selection that way as well. I'll also note that all of these units come in both a 200 volt class and a 400 volt class variety, right?
Yep.
So if your power service is limited to 200 volts, we have a solution for that. We also have worked with a third party, a separate company that manufactures slip rings to qualify that slip ring with our architecture. So it's connectorized so that if you have a turret application, for example, it will seamlessly integrate into our architecture. And we have one ring that we've worked with them for 24 axes and another unit that is good for up to 48 axes. Just a quick note on the power interface model. We just briefly touched on this. So this is the unit. It's basically the same dimensions as a 5700 dual axis inverter. So it won't really look any different than what's in the system already, if those are even in. Just want to emphasize, you don't need to have 5700 inverters as part of this solution. But if you're familiar with that footprint, that's what this looks like. Again, up to 24 axes of support with 15 kW. We make it easier as far as a maintenance standpoint. There is a fuse that is replaceable on the unit, and we make a nice little entry door on the side that allows you to replace that rather than having to send the unit back if that for whatever reason should happen in the future.
Is that what the circle, the beige circle or white circle thing is on the side there?
Correct.
I thought that was a fan. Okay, that's where the fuse is. Got it.
No. So let's see, anything else here? We do monitor output current and voltage um, very extensively, right? So we're not just looking at the total current running back to the power interface module. We're also looking at the current that's flowing between units too, right? As I mentioned, sometimes units are putting power back on the bus, sometimes they're taking it off. Looking at just the current coming back doesn't tell the whole story. So we monitor any potential overloads between the units as well.
Okay. Are these zero stack and you stack them right up next to each other?
Yeah, the PIMs can stack right up to each other in the cabinet. We
Nice.
can also zero stack the DSDs. You know, if you have an application where you have a number of motors that are in a cluster, so to speak, right?
Mhm.
Um, we have we can stack these DSDs right next to each other, and we have a available jumper that goes from unit to unit,
Oh,
so you don't have
nice.
to have a bunch of cable going out, coming back. So that makes for a real compact design if that meets the application. I'll skip over that slide. As far as key technology differentiators, again, extension of the 5700, so it gets all those features and functionality like adaptive tuning, virtual torque sensing. Um, it's designed for bus derived power supply capability. That's a little bit more of a future looking thing. That's something that's coming soon, but the devices are designed for that. In anticipation of that. They're very energy efficient. If you look at watts loss of this unit relative to our competitors or even our in-cabinet process, it's like a quarter of the watts loss that you would see compared to our unit. And as far as derating, derating is kind of a ugly word, right? Some of our competitors will derate up to 30 or 40% by virtue of having this out on the machine instead of a cabinet. Uh, the most that we see as far as derating is 10%. In actuality, some units will have no derating at all. And that has a lot to do with the technology that we're using. We have embedded or integrated accelerometers in all these units. This is something that we're looking towards the future in terms of analytics.
Mhm.
If you think about things that you want to monitor on the machine to try to determine if something is trending bad. You think about torque, right? Because torque is going to reflect something going on mechanically. Heat, if the unit is getting hot, certainly that is an indication. So we have a lot of integrated thermal sensors in there. We have 3 different sensors that we use to determine the temperature of the unit. And then we have the accelerometers, right? So if you think about where a motor is in the process, it has a bird's eye view of what's going on the machine, in the mechanics, right? If something is vibrating on the machine, even if it's not the unit itself, right? Normally it's something, a component like bearings or,
Mhm.
pulleys that are misaligned, things like that. That will be reflected in the vibration signature, right? So if you know what normal looks like, uh, we can compare that to, what's going on now. And, the goal is to identify, issues and localize issues well before they become reality. Again, we have all the safety and security. The integrated architecture provides that. So this is part of the integrated architecture from Rockwell. So it's network-based safety. We've got the SIP security in there. We have safety that is local, and we have safety that is controller-based. So it makes it easier to configure through one, configuration device, namely Logix, for the controller. So certainly a lot of benefit there. You're not switching between platforms all the time. And then a final note: these products are purposefully built for the on-machine or decentralized architecture. And that's not just this product, right? You may see other armor products out there as you're reviewing Rockwell products and offerings. And we're working very closely across Rockwell to make sure that we're consistent in the connectors that we use, right? The style, the diagnostics, things like that. So certainly something that makes it easier from a user perspective.
Now, and this may be off topic a little bit, but what versions of Studio 5000 are supported? Do you have that in a coming slide?
Hey everybody, just breaking in here quickly to see if you know about my other show, the Automation Morning Show. Every morning I go through over 200 industrial automation websites to find out what's new and happening in industrial automation, and then I go live at 7:30 in the morning to share what I found with the audience. Now the shows typically last between 15 and 25 minutes, and they're available on all the same platforms as the Automation Podcast, plus they're also available at theautomationblog.com. So if you'd like to keep up to date with what's new and happening in industrial automation, please check out the Automation Morning Show. And with that, we'll get back to this episode of the Automation Podcast.
I do not, but I can answer that
Oh,
question.
please.
Yeah, so V35 and V36, those are the latest ones, will support this. So the idea is anything after V35. V35 will need a separately installed AOP add-on profile in order to be able to commission this. When we get to V36, that will all be integrated into it. So, you know, fairly easy task to load the AOP with the V35 today. V36, I forget what the release date on that is, but it's coming up soon.
So as long as it's a motion controller, right? Even 53770s M's would support this.
Yes.
That's good. Okay, good. Yeah, because I know a lot of people haven't jumped to the 5380s and 5580s yet, so it's good to know. As long as it runs V35, you should be good to go. All right, and I apologize. I'll throw it back to you.
Oh, no, appreciate the input and questions. One thing I just wanted to touch on too is, the question might come up is when do I use a DSM versus a DSD? And in general, I think we kind of touched on this earlier, is that if you can use it in the application, the DSM provides the biggest, benefit in terms of reduced cabling and such. It has the smallest overall installation footprint, the lowest overall install cost, right? Because there's less cables. The simplest installation, you're only installing one thing in the same motor mounts that you would use otherwise. And then it has the VPL motor. Any VPL motor installations or applications would fit this ideally. It does have a nice safety features with Safe Torque Off up for SIL 3 and advanced safety up through SIL 2 or PLD. That's one thing that the DSD has as an advantage on because of that scalability I mentioned earlier. So it can get higher up in terms of a SIL 3 level for advanced safety features. But the DSD provides the greatest flexibility, right? So it allows you to pair up all kinds of different motors with it. You can reuse existing motors, which I think was brought up. A lot of times if you're looking to do switch architecture, you tend to avoid doing anything with the motors, right? Because now all of a sudden that is going to impact the machine design itself. It also gives you the capability of doing that auxiliary encoder input, right? So the reason it can get to SIL 3 is, in that situation, you'd have a safety encoder on the motor, and then you'd have an auxiliary safety encoder coming into the auxiliary. Those would be SIL 2 encoders, right? But at the end result is because of that redundancy, you get SIL 3. So just kind of the key highlights as far as what this product brings to the market. So it's a very innovative design given the power density that we have and the technology that we're using. Very low D rating, if any. It's very compact. Gives you all the benefits of the 5700. Plus, it's rated for IP66 and 67, which means for IP66, it's wash down rated, right? So for hose down, IP67 is really the test there is you immerse it into 2 meters of water. So in theory, particularly the DSD, it can run underwater. Not that there's a whole lot of applications for that, but it just kind of gives you a warm, fuzzy feeling, I guess. Energy efficiency, right? This allows you to right size your motor and drive pairing for better energy performance. Because the drive and the motor are one product, right? All of the You don't really need to worry about matching anything there, right? It's you select the unit that you want. It has a certain torque and power rating, and the drive that you need comes along with it, right? It's field mounted, so you don't have to worry about the costs associated with mounting an enclosure and the climate control that comes into play when you start putting all these heat producers in a cabinet. The integrated vibration sensing we think is going to be a huge addition to the marketplace to give you that insight on the vibration, which you'll be able to capture that as fast as every 375 microseconds, and it will be captured in sync with torque and position and all that. So you'll be able to see all that information all at once on the same timeline. A lot of exciting things coming down the road in terms of how one could use that. I know we're working on some things at Rockwell to kind of capture that ability to transform data into information. But we're really excited to see what our customers do with it too, right? The Rockwell team is still a limited subset at the end of the day, even though we're a very large and very capable company. The imagination of the whole marketplace is extremely powerful. So we don't want to lose sight of that. I think I mentioned the power range where we go all the way up to 5.5 kW. We're looking at opportunities to go higher and lower in power range as well as we grow out this portfolio. And we mentioned safety and security as well. That just kind of comes along with the fact that we're an extension of the 5700 platform. So key benefits. Right. So I just kind of put these on the slide deck or in this presentation just to bring it home as far as what you can achieve by using this product. So increased uptime, right? So we talked about the need to be able to maintain your production, keep product flowing off the end of the machine. By virtue of being able to see things faster in terms of issues that might be going on the machine, maybe you can do that, what needs to be done in a preventative maintenance schedule, right? Instead of interfering or interrupting production. When we go to, if there is a need to replace a unit, it's really just take out the old unit, put the other one in place on the machine, connectorize it, and away you go. Lower total system cost, right, is another key takeaway. You can reduce cable terminations by up to 90%, right? So think in terms of, I'm sure a lot of people listening actually have a number associated with how long it takes to do terminations. So think about reducing that total amount of time that it takes to terminate a machine and all the potential for human error that comes along with terminations. And in this case, it's reduced by 90%. There's fewer parts, there's fewer cables, right? The motor and driver combined, so it's not two parts there when you're talking about the DSM. Closure sizes go down, so obviously a smaller cabinet should result in lower acquisition costs. And overall, when you put these all this together, we estimate that installation costs will be lower by 30% on average. From an improving productivity standpoint, again, this is a modular architecture. So that brings up all kinds of possibilities as to how you manufacture a machine and how you maintain it, right? How you add features and functionalities in the future. So this architecture gives you that flexibility in a really small footprint. As far as sustainability, right? I mentioned the fact that with the power technology that we're using, the amount of lost watts is significantly decreased. We also have a very low derating associated with this, which means that whereas in other cases you might have to buy the next size unit up because of losses, here you can pretty much just say, okay, what would I use as a VPL normally, or the motor, I should say, and just use this drive instead of the one in the cabinet. So.
I am thinking when you were going through improved productivity and covering that again, it really makes the servo like distributed I/O, because now it's not a big mod to the cabinet to add a new servo in there, right? You just throw it on the network, throw it on the chain, and you got another servo. You can actually design ahead for that, saying, hey, if we had those two other diverters in the future, or those two other stations or whatever, we'll just make sure we have enough power, and we'll just plug and play and add them to the system, which is really cool.
Yeah, exactly. Yeah, I know we covered a lot here. I could talk about this all day, right? It's a passion of mine. But I will put out there that if anybody would like to learn more about this, please contact their local distributor, or Rockwell technical consultant or architect to review this architecture. And certainly, by working through them, I'd be more than happy to join the conversation as well at any time. So appreciate your time today, and hopefully this was a benefit, and you're as excited as I am about this new architecture.
Well, John, I think I really appreciate coming on the show, and looking forward to it. Would this be at Automation Fair?
Yes, it will be at Automation Fair. It'll be in a strong presence there relative to the product. We also have, if anybody's out there, Pack Expo will have at least 2 machines out there as demos showing this product as well.
Oh, nice. Great. Well, I really appreciate you, John, coming on the show and taking us all through this new product line. I learned a lot about it, and I'm sure the audience did as well. And just want to thank you for coming on the show and bringing us up to speed.
You're very much welcome.
Well, I hope you enjoyed that episode. I want to thank John for taking time out of his busy schedule to come on the show and bring us all up to speed on Armor Kinetics. Now, if you did enjoy this episode, please consider giving us a like, a sub, and a share. It really helps us grow the audience and find new vendors to come on the show. And if you want to get in touch with me or follow me, you can do so over at automation.locals.com. That's our own industrial automation community. You'll also find all of my training courses over at theautomationschool.com. And with that, I want to wish you all a courageous, fearless, and awesome week. And until next time, my friends, peace.